Welcome to join our training course Database Design and Database Management. And in this lecture, the introduction, I will walk you through what is the database, what is the database design, and I will cover what we will learn in this training course. So let's start by the database first. Database is one of the key components of your application infrastructure. Just an example. When you develop a website for user to register to your service, he click the register button. Then the web browser will send the data to the web server. And then the web server will process the data. Finally, he will save the data in the database for capture for retrieve it later on. In short, the database is used to store long-term persistency data. And for easy to understand and for you have a full picture, throughout this training course, we will develop a online photo album system, the database of online photo album system called Moments. And the Moments systems will store following information: the photos, uploaded information, albums, upload history, and comments. The database is a key component of your software. It has a big impact of the software performance. For example, you have a system to load the photo from the database. If you have a bad database design or a bad maintained database, you may have to take a long time, say 4 seconds, to get one photo. But if you have a good system, good database design, you can retrieve the information immediately, say just half seconds to get the photo. The database design in the database role is a blueprint of your persistent structure. When you need to save the information in the database, you need to have some way to design, to visualize, or to structure what you need to save. So why we need a design? Let's take another engineering discipline as an example. In civil engineering or in building industry, when you build a doghouse, you don't need any design. You just do it by yourself. You just need to buy enough materials and make your hand dirty to build a house. But if you need to build a high-rise building, like a 50-floor high-rise building, you can't do it by yourself only. You need different disciplines. You need architect, you need engineer, electrical engineer, civil engineer, etc. to work together to build the things. In this case, you need the blueprint. The blueprint is for all the stakeholder or all the participant to understand what he need to do and what he need to integrate to others. This is the same as software engineering. If you just build a very simple applications, you just do it by yourself. But if you need to build a large system like a supermarket information system, you can't just do it by yourself. You need to have a team to work together in order to build a system. In this case, you need a blueprint, and database design is one of the blueprint of this system. So the different team member can understand what he need to save, how to retrieve the data by just looking at your database design. A good database design serves the goal of maintaining the balance between the database size and the performance. So let me show you a simple example about how to balance this size and performance. Here we have an example that we have a photo. Under the photo, we have the uploaded detail, like who uploaded the photo. This is uploaded by a person called Chris Wong. You can imagine you can save in database like that. You have saved all the photo and uploaded detail in one single table. The benefit is when you want to load the photo, you just need to run single query on the database, and no join, no we select. You need to get the upload information together with the photo. But the problem is you may create a lot of redundant data, like you have a lot of Chris Wong along with all other duplicated data. So the idea could be we can split the photo and uploader in two tables. In this case, the photo saves the photo information, the uploader saves the uploaded information. The benefit is we can reduce the redundant data, and when you update the uploaded information, you don't need to upload a lot of rows in the database. So this is the idea of the database design, and we just do it virtually on the PowerPoint, but it's not easy to draw such things all the time when you design the database. So we need a database design notations. We use the entity relationship diagram, ERD, which is a very classical database design diagram. The ERD is a language for expressing the database design, and it is a visual language. It is graph. You can easy to understand, easy to draw, and ERD is facilitate for communication. The communication here we means to face-to-face communicate. I tell you this entity and the other entity, and also for the documentation features. Then you can get the idea later on by check out the documentation. ERD also presents the data structure and the relationship between this structure. And come back to our example, the uploader, the photo. If you present the photo in the ERD, it will like that, a round rectangle. It's stored about this is showing the data objects about which information to be collected, which information to be saved, and detailed record can be shown in the record editor. We will cover this later on in the coming lectures. So you can see we store the title, the upload name, photo album, and the address. And this kind of data is not part of the design, but it is good for understand how to make use of this table. And as we said, we need to split the uploader and the photo information in two tables. So now the photo in one table, or we call entity, the uploader in other table. So you save or following information for the uploader. So you just have two records of the uploader, Chris, and then you have a lot of photos, and the photo have a foreign key called uploader ID to link to the uploader. We will cover the details about how this linking work and how to present in ERD. Don't worry, I will cover it in the coming lectures. And so let's review what we will cover in this training course. This course will cover the database design, how to use the visual language, the entity relationship diagram, ERD, to design the database. And we have a section to talk about how to generate your design into a production database. Or if you already have the database here, you want to understand the database structure and their relationship. We also talk about how to reverse the database into the database design. So you got the diagram back by the database. And the database design is not a one-shot activity. You need to keep updating, keep maintaining your database, to adding a new column, new entities, or new relationship based on the new requirements you need in the future. So we'll cover how to maintain the database design, is including how to patch your current version database to the new design. Also, we will talk about the data dictionary, which is to generate the full detailed documentations of your database design. Then you can share with your team member that we can work together to deliver the informations, to deliver the systems. And this is one of the reasons why we need such a database design. So we don't just get the database, the production running database. We also got the detailed design blueprint in whatever you like, a Word format, the PDF format, that for documentation purpose and for your team to get understanding in the future. To make sure we keep focus on the best value we can provide, we will not cover such things. We will not cover how to discover the database table, the technique to identify the database table. We will not cover normalization. You can find a lot of information from the internet. And we will not talk about the SQL. We will not tell you how to write the select statement to query the database, to update the database. And again, this kind of information you can find on the internet easily. So we focus on talk about the design and management things. And in this training course, we need following software. We need the visual paradigm, and you can easily got a 30 days the free evaluation. So you just go to www.visual-paradigm.com/download to get the software. And when you run the visual paradigm, you just need to select evaluate. Visual paradigm support the Windows, the Linux, and OS X, OS 10. And this training we will base on the Windows, but the same steps, almost the same steps, can apply to Linux and Macintosh and OS 10 user. And the database management system in Visual Paradigm support a lot of different databases, like most popular Oracle, the MySQL, the SQL Server. In this training course, I will use the MySQL for the demonstration, but again, the same or similar steps can apply to other databases with just selecting different options, so you will know how to do that. So thank you very much for attending this lecture. Please continue to the lecture number 2. Entity and column. In this lecture, I will give a basic introduction to entity and column. Let's start talking about what is entity and column. And entity and column is the fundamental element of the database design. So this is the elementary things you will do. And the entity and column defines how data are being stored in your database. For example, you can put everything in a single entity and then put all the attribute in the column of the single entity, or you can spread it to different place, different entity to store the data. In short, the entity is the generalized form of your data. Just like we're talking about the photo, then we will store the photo information and the uploader information. We can take a look on this example. We have a lot of photo data. The photo ID, the title, the uploader name, phone number, uploader address, etc. We have live record here. We focus on the first 2 columns, which is the photo detail. It's talking about the title of the photo you will give to each photo. And you can see we have a photo entity defined to store this data. And these 2 columns of the data will become 2 columns of the photo entity. And if you look at the photo ID, it is an integer. And we will put the integer in the ID column, in your entity ID column. And the title is a text. Then we will put a text type. In database, it is a varchar type representing a text. And you give the length. And then the right hand side is the uploader information. We split it in 2 tables because the uploader will upload more than 1 photo. We will have another lecture talking about the relationship. Then the uploader table, the uploader entity created. Again, each column will become the columns of the entity. We just repeat this step to analyze what data we'll store. Then we will create the other entities that we store the data in the future when we develop the system. Let's move on to talk about how to draw the entity and column. Before we draw the entity, we need to create the entity relationship diagram, or in short, ERD. ERD is a graph of entities and their relationships. We suggest to create multiple ERDs in your project rather than single giant ERD contains everything. That can increase the use readability and understandability of your design. To create a ERD in Visual Paradigm is easy, straightforward. You just go to the Diagram tab on the menu, click New, then you will see a new diagram dialog box. Enter ERD or entity relationship diagram you like. We will search and filter. Then you enter the name. The second thing is very important. You need to decide where to store this ERD. If you have no ideas about the model repository concept, please refer to our Visual Paradigm Essential Training course. You can find it on the internet. It is free of charge. You can decide to put it on the root or put it in certain model that contain the ERD. And then optionally you can write the descriptions. Then you click OK. You will create a brand new ERD, and you can specify it is a conceptual ERD, logical ERD, or a physical ERD. So the brand new ERD created. Let's take a look about how to create a ERD in Visual Paradigm. Here I have the brand new project. You can go to the Diagram tab and click the New. Then you will see a list of diagram. Because I created the ERD before, so we saw it on the top of the list. Or you can type ERD to just filter what you want. If it doesn't show up on the first row, you just click Next. Then you give the name. This is ERD1. And you can specify the model. Since this is the new project, so no model specified it, I just put it on the root, and you can give some descriptions if you like. And then click OK. Now you can select this as a conceptual, logical, or physical. Let's create as a physical. Then we move on to talk about how to create the entity. To create the entity is also very simple. You just need to select the entity from toolbar, create on the diagrams and give a name, etc. You just hit the enter to confirm, so it's easy. Again, if you have questions about drawing the diagram, please referring to the Visual Paradigm Essential Training course. And then we move on to talk about to create a column. To create a column, you just right click on the entity, select the new column, and then you can create a new column, or you use the shortcut key alternate shift together with C, and then you can enter the name and type you want, and also the modifier. If you want to define it as a primary key, you can define it at a +, at the beginning, and then give the type and then length, etc., and hit enter to create. Let's take a look. Okay, I just create the entity. This is a photo. Let's zoom in to make it easy to read. Right click, new column. Then you can give ID. This is integer 5. Things like that. You can continue. This is a title. Chart 120. And if you find that enough, you just hit the escape. Then you will finish the creations. And you want to define the ID as a primary key. You can open the specification dialog box to create. We will talk about in the coming lecture. Or you double click it and add the plus. Then the first column will become the primary key. So it's easy. Let's summarize what we talk about in this short lecture. We talk about introduction to the entity and the column, just basic concept, and how to draw the entity and column in Visual Paradigm. Entity in detail. In Visual Paradigm, you can specify the detail of the entity through the specification dialog box. You specify the entity detail for following reasons. You need to construct the database, so you need more information for not just displaying on the screen. You need to generate to specific database engine, so you need to specify the detail. And also you can maintain the common understanding of the entity. So you can specify something like a type and the length of the type. Then any people in your team can understand we got this entity or this column in specific detail. And the third purpose usually is you need to keep the record. The software development is not just one-off activities. It is on and ongoing. So if you specify the detail correctly, when you come back, you can check it out, why we have such design or why we come to this point. So how to open the specification dialog box? It is very easy. You just right click on the entity and then select the open specification menu item in the pop-up menu. Or there's another shortcut. When you select the entity, you can click the enter. You can just hit the enter key. Then you will see the specification dialog box like this for the entity. Let's walk through some important properties in the specification dialog box. First is of course you have the name, but the first property below the name is called domain. Domain is a name set of properties that can be reused by any entities. Okay, it's very abstract. Let's give an example. For example, you have a log. You can define the log as a domain, and when the entity apply the log domain, it will come along with all the properties you set. For example, where the schema it is, or what columns included. For example, you also have the transactions that can be used as a domain. Then when you set the table as a transaction, then you will have all these columns come along with your entity. Let me just show you how to define the domain in Visual Paradigm. Here I have an empty Visual Paradigm project, an empty relationship diagram. I just create an entity. I say this is a photo log, for example. It's used for store the log of the photo. Then I can right click and open the specification. Now the dialog show up and I can go to the domain. I can configure the domains. And now it's empty, of course, because this project is empty. Then I add. Now I go to the domain. I can define this as a log. Then I can specify the schema or things like that. Then I focus on the column. I can create a column. For the log, I will have the log time, which is the property. The type is time. And I also have the description, event description. And this is a kind of varchar. I define 255. And then it's okay. Now I have the log domain. Then I can specify the log domain on it. After you specify the log, you will see the column will be created. So in the future, if I create another entity, say this is a member log, then I right click, go to the specification, and I apply the same domain log. Then you will see it also come along with all the columns required. And the best things is if you change the log domain, all the related entities will be updated accordingly, so you don't need to go through every log table and then add the columns you want. Okay, let's come back to the slide. To use the domain, it is used to maintain a company enter the value or descriptions that you can use in different entity, and it is reuse it in other entity when you need it. I just demonstrate to you. So the benefit is save time in create similar entities like log transactions, and other benefit is to keep the data model consistent. Then the second property we look for is a full text index. This properties is only available in Microsoft SQL Server. So if you specify this property, it's only effective when you generate MS SQL. And the definition is used to specify the field which can run in the full text engine, just like a search engine. Then when you query on specific text, it is very effective. For more detail, you can visit Microsoft website you see on the bottom of the slide. Discriminator column. It is a very specific for object to relationship mapping. When you decide the database, it's used to store the data. But when you're doing the programming, you need to load the data into the memory in order to do your work. So you will have a corresponding class diagram in your memory when you're doing object-oriented programming. In Visual Product, we can generate both the class and the database for you, and we use an open source object persistent framework called Hibernate, which is very powerful and very popular. The idea is you decide either the class or the entity, then we can help you to synchronize. The discriminator column is used to solve one problem. When you're doing the class, when you're drawing the class diagram, you define the class hierarchy. You can use the generalization to specify the superclass and subclass. This is an example that we have a photo class and we have a different subclasses for different properties and different behavior. We have a wildlife and the landscape and event. You define it in the class diagram, and during the programming it is very natural. But how about the database? We need to save this object to the database. To solve this problem, we can put all these classes into a single table called photo. So it includes all the attributes in different subclasses. And how to distinguish this entity, this row is correspond to which objects in your memory. We need a discriminator column. So the idea is something like that. When you save in database, you have the art museum, then it is a landscape. You define landscape. So when you load up into the memory, we will load the landscape objects rather than the wildlife or event. And if you take an Olympic game, this is a kind of event. So the engine will understand when we reach this row, we will return the event object to you rather than the landscape or wildlife. So it is so powerful, the discriminator column. By definition, the discriminator column is used to store the value to identify the type which belong to which class. To use it, it's easy. You just select the column as a discriminator column and make sure after you specify this column, the ERD is synchronized with the class diagram. We have another lecture talk about the synchronization of ERD and class diagram. And you will set the value when insert the data into database. If you use the Hibernate framework, you don't need to care to set this value because the Hibernate will set for you. Version column. The version column also used exclusive for Hibernate. It is used for hold the version number. It is a number value for Hibernate to do the locking. If you load it up in different thread and you write it to avoid overwriting each other, it used it for the locking. And the usage is simple. You just select the column to store the version number and then store the version data when generate the ORM. And again, the Hibernate will help you to do this. The schema. The schema is to define the container to store this entity in your database engine. So it is a logical container like a package. The schema, when you set it, it only effective when you generate database. If you decide the ELD for logical or conceptual idea, then you don't need to define the schema. It's just for generate database. So use the schema. You just need to go to the schema value and then type in. The schema field will have the compression support. So if you define like the core before, then you define another entity, you can see the core. You can see the core in the list, so it's avoid mistake typing. The data model. We talk about a conceptual model, logical model, and physical model. In one diagram, you can specify it as a logical or conceptual. If you want, you can specify different entity in same diagram for different logical model. You can specify it as a conceptual, is a summary level. A logical, it is fully attributed and normalized it. And the physical is for ready to generate a database. The table space. The table space is only available for Oracle. So if you generate to another database engine like MySQL or MS SQL, it isn't effective. The table space is a logical locations where to store your table in the Oracle DB. And this is a kind of database generation property. To use it is simple. It just define the table space lookup, and then you can select the table space. And it's better to use the lookup rather than type it in. The reason is if you type it wrong, you will put it in the wrong table space, which is not you expected. And the DDL course. The DDL course is a data definition language. It is the syntax for define the data structure. So it's just like the create table, drop table, order table. And the DDL course you define here will be append to the end of the generated statement, generated data DDL when we generate database. So you can write something like on commit, delete rows, things like that. This is for specific database. It's based on which database you use. You need to write the correct syntax on that. And finally, the description. If you have attend our official program essential training course, you know what is the descriptions. The descriptions is used to describe the table in a detail in a textual form. The description text you write here will be used in generate the data dictionary. The data dictionary is a kind of document that for the developer or the database admin to understand the data structure. So the description will be generated there, and it's for documenting the database. So when someone look at your table and want to know what this table used it for, instead of walk through each columns and guess what it is, he just need to read the description and understand what it is. Let's summarize this lecture. We talk about how to open the entity specification, and I walk through various properties for the entity. Thank you very much for attending this lecture. See you soon in the coming lecture. Column in detail. You can configure the column detail by using the specification dialog box. To open the specification dialog box, you just need to right click on a column and then select the open specification. Or you can select the column, just hit the enter key in your keyboard. Then you will see the open the specification dialog box of your selected column like this. Let's walk through the different fields you can set in the specification dialog box. The first one is the domain. This domain is same as the domain we introduced in the table. It also contains a set of reusable values that you can reuse when you design your database. The usage is you create the domain, and then you set the type, length, and this default value, etc. Then you can reuse another column when you need it. The benefit of using the domain is you can save the time in creating similar columns. You say, for example, you have the datetime format for your company. You don't use the system datetime. You want to use your varchar format to store in your own format. Then you can define as domain. And also to keep the database design consistent. Let's take a look about how to set the domain. Here I have the photo and uploader entities. For example, I want to add an upload date to the photo table. I just right click and add a column, say upload date. Then I right click, open specifications. To change the type of the upload date, you can change the type by select the type, but now I want to show you the domain. I click on the domain and configure domains. Then you will see a configure domain dialog box. I don't have any domains right now. I just add a new one. You can give the name to the domain. This is iDate. And then I just select the varchar, and the length is 8. For this domain, the age, you can write the description, say the type is year, and month, and the date, something like that, to as the descriptions. I click OK and OK. Now I can choose the iDate as the domain type. Click OK. Now I assume I want to also add the date to the uploader. I want to say the join date. The uploader join our system. I can right click, open specification, and then I can select the iDate again. Now you see both is varchar 8. You may say, why don't I just set the domain? The reason is if you want to change your mind, you right click, open the spec again, and then you can configure the iDate. Now I change my mind, the iDate will change to 10. And also store the hyphen between the year, month, and date. I click OK. OK. Now you see both the upload date and the join date are changed to varchar 10. You don't need to go through all the table and change by yourself one by one. And then we look into the type. You can identify, you can set the type of the column you want. And for example, the integer, the char, varchar, etc. And different vendor, different database vendor I'm referring to may support different types of different database type. So say for example, the MySQL support the decimal, Oracle support the flow, timestamp in Oracle, and date time in MS SQL. You can configure the database type by using the tool, database, DB, and DB database configuration. First, we go to the tools, and you find the DB button in the toolbar, and then you click the DB, click the database configuration, and then you will see a list of database supported by Visual Paradigm. Now I select MySQL. Just make sure you understand I have the type is in MySQL. If I change to use Oracle set as default and I click OK, now you see it's changed to number. In MySQL, the integer stored as in Oracle is stored number. Visual Paradigm will help you to change the data type based on your default database setting. So if you want to generate the database script for different types of database, it's easy and straightforward in Visual Paradigm. And then you can configure the length. The length is about maximum allowable data to store into that. If you're talking about the varchar, that means how many characters you can put into this column. The user type. User types is for you to define your own types rather than using the database built-in data type. For example, you use the Elum to build your own settings. And the user types only effective when you generate the database. Under the user type, you will see the default value. The default value is when you insert the data into the database, into this column, and you don't specify the value, then we will set it to automatically for you. And then the ID generation. The ID generation property is for you to select which strategy you want to generate to produce the primary key column. And we have different settings. Just walk you through few very commonly used. The assigned, that means when you insert the column, insert the data into the database, you need to set the ID by yourself. And you need to keep it unique, and you need to make sure it is not null. And the other things, other commonly used is the GUID. You can request the database to generate the GUID. It's only supported in MS SQL and MySQL. And the other things we usually use is the lative. The lative is a default one. The lative one means the database will be automatically generate the value to your primary key when you insert the row of data into the database, into the table. We will have more about different types of strategy later on when we're talking about primary key. And also the sequence. In Oracle, DB2, and PostgreSQL, we can define the sequence to generate the ID. It's similar to the lative generate, but you can define the range and the generation strategy for different loading and different usage of your database. After that is the check constraints. It allows certain value to be filled into the column. It's used when you generate database and you insert the data. If the value is not fall in this range, this constraint, then you will got exceptions when you insert data into the table. The generated property. The generated is only used for the ORM, more specifically the Hibernate. When you generate the Hibernate, then you can instruct the Hibernate to, if you set it to always, then no matter you update the row or insert the row, this column will be set as last modified. So it's used when you use the Hibernate. We will cover the Hibernate later on in this training. And sync to attribute also for the Hibernate is allow you instruct the database table to synchronize to the class diagram to corresponding class, and the column name will be linked to the attribute name, and the column type will be linked to the attribute type. And then you see the DDL clause. The DDL clause is a text that you can append to the end of the insert the create table statement. So if you have some very database specific and we don't support in the above property, then you can append the text, say something like the special constraints only support in your database, then you can insert here. Under the DDL clause, you see the descriptions. It is text, rich text for you to describe the column in detail. It is useful when you creating the data dictionary. Then your reader can understand what this column is used for. And when you generate a database table, it will show as a comment. So if you generate the DDL, you will see the descriptions enter here as a comment. Under the description box, we got 4 checkbox. The first one is include as a primary key. The primary key is a unique identified value for each record in the table. We talk about more primary key later on. And one entity can have 0 or 1 primary key. And the primary key can formed by multiple columns. So you can combine multiple columns to be a primary key, but each table only have 1 primary key. And then the allowable checkbox, if you take it, that is allowed to insert a low value. And this situation is applicable when you set it to allowable. The value to be filled later on, or the value is optional, it can be unspecified. And make sure when to use the nullable field and it does not break your business rule. For example, if you if you require the user to input the social security number, you make sure the column is not set nullable to true, so don't tick this box. And next to the nullable is the unit. It is used for ensure the data in this column is not duplicated across the whole table. And it can be null. And the index is used to improve the speed of the data retrieval, and you can set the column to be indexed. Then all the data in this column will be indexed by the database engine, and we will look at the index in more detail. Index. As we said before, the database is the key component of your application. So if you have a good performance database, you will get a very fast responding application. The index is one of the approach you can speed up the database. Let's take a look about if we do the database without the index. Say we want to find the uploader email address is tony.stanley.ca@gmail.com. Then the database need to walk through row by row, and then finally identify this is the row we're looking for. If you have the index, it can speed up the query of specific record a lot. Let's take an example about to use the binary search index. The same data set we have, and then we set the uploader email address as the index column. Then we will have an index table to store these values, and the index table will be sorted by using different algorithm. Let's say for the simple one, we sort by alphabetical order from A to Z. And then when you want to search the specific email address, then we don't need to search from beginning to the end. You just need to first find the middle one. Then you compare, is the Kim is bigger than or smaller than the Tony. After that, you go through another directions to search to scope. Finally, you just go through 2 or 3 paths. Then you will find the Tony.Stanley. Then you can link to the corresponding row of the actual data. So you see it's much faster. If you just have hundreds of rows, it doesn't matter. If you have millions or billions of the row of data in your database, then the index can really speed up the searching. And again, your system is not using by single user. It's supposed to be used by a lot of users. So then you may ask, why not set every column as an index? But we need to have some consideration. First, you need to consider the storage space. If you set the column or columns to be an index column, then you need more space to store the index table. It makes sense. You store extra data, of course. The consideration tool is the performance. If you write the data into the table, it not just write to the table you define, it also need to update or insert the data in the index table in order to make sure when you search the data, it got the accurate result. So when you pick the column to be the index or the row, which columns to be the index, you need to think about, is this database is a read more than write? If you keep writing, say I write thousands times, I just read it once, then it doesn't make sense to index it. If you have the data, like usually the user profile in our example, the upload information, the user don't update the information so often, so it's good to index it. Then when we read it with the photo, we need to locate the corresponding uploader. Then the index can take a great advantage. So to set the index in Visual Paradigm is easy, and you have 2 options. You can set the index in the table space. You can have multiple columns combined to be the index, or you can specify single column as index. Let's take a look about table space. To set the table space is easy. You just right click on the entity and open the specification. After that, you go to the index tab in the specification dialog box and click the add button. After that, you can select which columns you want to be the index, and then move to the right hand side. Left is the all column, right hand side is selected, and then click OK to confirm. Then you set this column to be the index. You can set the column as an index by just right click on the column and then select and click on the index menu item. Then you will set the column to be the index. And remember, when you set to index, you need some extra space and extra CPU when you write the data into the database, into the table. So use it with care. Let's summarize what we talked about in this lecture. We talk about how to open the specification in the column, and I walked you through different properties that you can set into the column, and also introduce the idea of index and how to use the index when you're using the visual paradigm. The 3 levels of ER model. We may draw different types of database design diagram. Basically, we can separate in 3 levels. They are conceptual, logical, and physical. The conceptual model and the logical model is not for the database generation. It's more for the discussions to verify the design and the requirements. While the physical database design is for generating the physical database for the running system. Let's just walk through what are they. The conceptual model. This is a very simple conceptual model of our example, the photo album software. It's overview the business information is needed. So we have a photo. We need to store the location. We store the album. Store in the album. And you can see one album have a multiple photo, etc. And it only stores the main concepts. When we move on to the logical model, we'll have a more detailed representations of the data and the structure of the data. And we set the data type. We basically identify the type to store certain information. And the entity may be normalized. You see now we separate the photo and the member into table instead of put all the member information into the photo, the entity. And sometimes we also denormalize that. We may consider something like the upload date. Instead of searching all the upload history, we just store the denormalized data. In physical database, which is for create and maintain the database in long term, and we will change to use a database when the specific type, like if we were using Oracle, we will use the number instead of the integer. And the foreign key are added. If you are using professional database design software like Visual Paradigm, the database relationship, the foreign key and the primary key will automatically sync, so you don't need to worry about to keep them synchronized by yourself. And also we add some index constraint. Say we need to search the email is so often, so we index the email column. And also the linked entity. We have a tag and a photos. There are many-to-many relationship between text and photo, but we cannot have a many-to-many relationship in the database. So we have a link table. So we have a one-to-many relationship from tag to tag photo, and then another one-to-many relationship from photo to the tag photo. Let me just show you how to create different types of ERD in Visual Paradigm. To create an ERD is easy. You just go to the diagram menu and you click the new diagram button, or you can use the shortcut key Ctrl+Shift+N pressed together, which is new. And then you can search the entity relationship diagrams. Of course, it's on the top already. And we click next, and this is a photo album. Then you see the entity relationship diagram is created. You can choose this as a conceptual, logical, or physical. Let me just take it as a conceptual. When it take it as a conceptual, you see the icon already changed it to green. Then when you create the entity, it's in the green color. Let's create another entity relationship diagrams. I just name it logical. And then we pick the logical, and then you see the color is different. It's between yellow and orange. It's between yellow and orange. And let's just create a physical. Let's just create a physical. And you just take the physical, and then you see the color is different. This color in the orange. You can see the difference. The conceptual one is green, the logical one and the physical one in different color. The color code gives you a very convenient way to identify which types of entity relationship diagram it is. Let's summarize what we talked about in this lecture. We overview of 3 levels of database design: the conceptual, logical, and the physical. I showed you a sample ERD about these 3 levels of database design. So thank you very much for attending this lecture. Key and relationship. In this lecture, I will walk you through the primary key, foreign key, and the relationship in ERD. Let's start by talking about the primary key first. Primary key is a table column. It is a column or a set of columns. It should be a columns, multiple columns, which uniquely identify the record you want. Let's take an example. So we have a member table here. We have so many records. If I ask a question, can you give me a phone number of Nancy Ward? So the problem is we have 3 Nancy here. Which Nancy you want? In this case, we need to introduce another column called ID to identify which row of data you expect. So you can select to say, I want the number, the phone number of ID number 2, say something like that. So the presentation of the primary key is a key. You see the key icon on the left hand side of the column. When you're picking a column to be a primary key, you need to check with following conditions or following things before you pick it as a primary key. Is it unique? It is unique to identify the row of data. Is it mandatory? So the primary key cannot be null or empty. Is it constant? You will not change the value of the primary key. Let's check each column. The member name, is it unique? May not. We see the Nancy Ward, we print the name. Is it mandatory? Yes, it is mandatory. Is it constant? Yes, it is constant. At least we will not change our name so often, but it's not unique, so we can't use it as a primary key. How about the social security number? Is it unique? Yes, it is unique. At least we don't have 2 same social security number, same security number for 2 persons. Is it mandatory? It is a yes or no question. If you only serve the United States residents, that can be fine. It is mandatory. But if you also serve other countries' customer, then you can't use the SSN. Is it constant? Yes, it is constant, but it is not mandatory if you want to serve international customer, so we can't use it. How about the email address? Is it unique? Yes, it is unique. You can't go to the same email address. Is it mandatory? Yes, it is mandatory. Is it constant? Also, yes and no question. If you allow the user to change the email address, then it is not constant. Finally, how about to have a computer generated ID? Is it unique? Yes, it's unique. Is it mandatory? Yes, it's mandatory. Is it constant? Yes, after you generate it, you will not change it, so it's constant. In this case, we will pick the computer generated ID as a primary key. Primary key can be a single column or group of columns. When you define more than one column as a primary key, we will name it composite key. Let's take an example. Here we have a photo and the photo sharing table. Each photo will have its role, but one photo can share to more than one member. In this case, the photo ID in photo sharing table is not unique. We are allowed to share the same photo to multiple team members. And even the team member is not unique because he can have multiple photos shared to him. In this case, we need to combine these two columns to form a unique primary key. Then we call it a composite key. You will see both columns will have the key icon on the left hand side. Regarding the primary key, we also need to think about how to assign the value to the primary key. Basically, there are three popular approaches. You can use a computer generated ID. You can specify the ID by your program manually, or it can use the sequence. Let's take a look on each. Regarding auto-generated ID, it is very common to use and very efficient. When you insert the data into the table, the database engine will assign a new ID to your row of data, so later on you can retrieve it by the ID. The second option is to specify the ID manually. And take an example for the SSN. When you insert the record into the table, you need to provide the SSN at the same time. The value is mandatory. It cannot be null or empty. And the example of manual assigned primary key could be the social security number, email address, if you don't allow the user to change the email address, or the ISBN, which is quite unique. The third option is the sequence. The sequence allows the database to generate an ID for your new record. But the generation is based on your setting, including the interval, mean, and max value. And the sequence can be defined in different database engines have a different sequence defined mechanism, but the idea is similar. If you want to define ascending sequence, you specify the mean value start from 1, a max value really big value. Make sure it is enough to accommodate the number of rows you want to insert. And the max value to start with, which value we start with 1. Increment by how each value will generate it. We say 3. The cache, usually we'll have this property to allow the database engine to optimize the speed. Then you can cache some value on the memory. In this case, when you insert the data, you will got 1, 4, 7, or 10, etc. Let's take a look on descending sequence. Same as the mean value and the max value. We start from the max this time, and the incremented by is a negative value. Then we will start from the highest value and go down. And there's no cache, so when you insert the record into your table, you will got the ID pattern like this. Okay, let's see how to define the primary key. Define primary key, we have two approaches. One is you can double click on the column, and then at the beginning of the column you type the plus and then press enter. Then you confirm the editing, you will see the key icon is showing. The second option is you open the specification dialog box we talked about in last lecture, and then you go to check the include primary key checkbox. Then the column will become a primary key. After talk about the primary key, let's talk about the foreign key. Foreign key is a table column. Again, it's the table column. And uniquely identify a record in another table. So it's used to identify the record in other table. Primary key is in our table. And let's take a look of an example. Here is the photo table we designed at the very beginning. You see we have the photo detail, the ID, the title of the photo. And on the right hand side of the table, you see the member detail. And we find that the value will keep repeating. You see Chris Wong repeats so many times. Then we decided to split into two tables. One is the photo with the ID and the title, and the member table to have the name, phone number, and address. Then we will introduce a foreign key column called member ID to link or to uniquely identify the member in the member table. This is the look of the foreign key you see when you're using Visual Paradigm. To use the foreign key is for you to uniquely identify the value in other table. Let's move on to talk about the relationship and the cardinality. The relationship is showing the foreign key, and the relationship and cardinality we find three common types. One is one-to-many, which is most popular to use. Another one is 1-to-1 or 1-to-0-to-1, which is optional or not optional. The third one is a many-to-many. Let's take a look one by one. The one-to-many relationship used when the record in the table can reference to multiple records in other table. For example, the member can upload many photos. So from the member side, we can identify many photos he uploaded. The customer can make many reservations. He can reserve many times. The document can have a multiple revision. And the one-to-many relationship and the cardinality is probably the most commonly used type. The second one is a 1-to-0-1. It's used to reference to another table, which is you have the record or sometimes have no record. An example is we have a blog post, we can have in single pieces of blog content. Why we need to separate it? Maybe it is so big, the content is storing the multi-kilobytes or multi-megabytes data, so we don't need to get it all by once. The customer can have an address info. It could be have address or he has no address, so we can save some space. If you're using 1-to-0 and 1, you need to use it carefully. As you can see, you just identify one row in other table. You may ask a question, why don't I just put this column in my table? Just put the address info into the customer. So if you split it, you got gain the performance on use less data. The reason is if you don't fill in the data, it saves the space. And on the other side, you lost the performance due to you need to more storage space to store the structure of the table if you have a data, and more complicated query. When you request the result, you need to join two tables together to return both the customer and the address to you. The conclusion is if your data don't have such referencing table, don't want to read the referencing table record, in most cases say more than 90%, then you can split it. Otherwise, we suggest you put it back to the single table. The many-to-many relationship. Basically, the relational database doesn't support a real many-to-many relationship. In this case, we need to break it down into pair of one-to-many relationship and have an associated entity, associated table between these two entities. And it's used to parent record to reference to multiple record in other table and vice versa. The example is the student can enroll to many courses and the course can be taken by many students. So it is a many-to-many relationship. Another example is the order can contain many products, while the product can also be added to more than one order. That makes sense. Otherwise, why we need to have a separate order. Let's take a look on more example about one-to-many. A member can upload many photos to our system. So we need a one-to-many relationship for the member and the photo. Let me just show you how to do this relationship in Visual Paradigm. Here I have a very simple table, the member and the photo. To create a one-to-many relationship from the member to the photo is easy. You just move to the top right corner resource catalog icon. Drag it to the photo table. Be careful, put it to the photo label rather than inside the column. We put to the photo. Then you will see there is a different options. You can create one-to-many, one-to-one. This is one-to-many. This showing on the top is because it's frequently used. Many-to-many, or in the reverse directions is many-to-one. Let's just click one-to-many. Then you will see the relationship specification dialog box showing up. Since you map one table to many, then you need to select the foreign key of the target table. By default, we will generate one for you, but in case you already have a column that can be used as a foreign key, you can pick up here. Let's just take the default one. Okay, then now you see the relationship is created and a new column called member ID is showed on the bottom. You can drag it up. The normal practice is we put the primary key on the top of the item list or of the column list, and then the foreign key, and then the normal column. Now we have the ID and the member ID showing up here, so it's easy. Let's take a look on this another relationship. You look at the blog post. We have the blog post which have one content. The blog post will have a header that is showing part of the content for the user. When you load up the start page, we don't need to load up whole content. So we'll have a blog post, and then the content we can store in a different table that to delay the loading to make it even faster to load up. We have the basic data of the blog, is the ID, title, summary, post date, etc. And the long content we will post into the content table, which just store the long text. Then when we show up in the front page, we don't need to load up the whole content. We just need to load up the blog post. To create a one-to-one relationship is easy and similar to one-to-many. Just move to the resource catalog, drag and drop, and then select the one-to-one relationship. Similar to the one-to-many, you also need to pick the foreign key column, or you can generate one as default. Then the relationship will be created. A photo can have many tags, and the text can also be tagged in many photos. In this case, we have a many photo tag to many text relationship. In database world, to do that, we need a middle table. We call this as a many-to-many relationship. We need two one-to-many relationship to form the many-to-many relationship. So we have a photo, and then we have a tag, and inside there is between them we have the photo tag table to make up the many-to-many relationship. To create the many-to-many relationship, also similar to the one-to-many, just go to the resource catalog and then drag to the target table, select many-to-many, then we will create the associative table for you. You don't need to do it yourself, you just name it, and then the relationship will be formed. So it's easy and straightforward. Let's summarize what we talk about in this lecture. We talk about the primary key. We talk about what is a primary key, how to pick a primary key, and we can make a composite primary key rather than just a single column key, and different kinds of primary key assignment mechanisms, and how to define the primary key in Visual Paradigm. We also cover the foreign key. What is a foreign key? Different cardinality. We talk about different cardinality and how to create a different cardinality foreign key in Visual Paradigm. Database view. Database view is a virtual table that provide the result set of a pre-established query command. So what that means, the database view is very similar to the table, but it doesn't store the real data. We just query the existing database table and show you the result. It is very good for simplifying the development by creating the view. And in this lecture, I will show you different approaches to create the views in Visual Paradigm. Let's talk about the concept of database view first. You look at these moments, the photo album software we're going to build in this lecture, in this training. We have the photo showing. You can imagine the photo are showing from the photo table. And we just used 3 columns. The first one is the photo ID. The second one is the title, just the title of the photo. And the third one is the photo itself. And we just need 3 columns, so we don't need to query all the column out. To do that, we can create a view. For example, we call it DL photo view. Then we just need to got 3 columns. We just got 3 columns and showing in the view. So when you query on this view, you just got all the data you want instead of a lot of columns returned. To create a view in Visual Paradigm is easy. Let me just show you now. Here I have the entity relationship diagram showing the moments, our online photo album software database. Okay, now you see the table we created, the entities we already created here. To create a view, first of all, we need to show the data record editor. So you can click the action bar and show the record editor. Now you see the record editor showing on the bottom, and you can adjust the size by yourself if you like. Then we create the views. The view is similar to create the entity. Just create a view on the database, and then we name it DL photo view. Okay, and then you can click the plus sign in the view editor. To add the entity you want, you can use the search, the photo, and now just make it even bigger to see. Now you see we have the photo table showing here. Then we can decide which column we want to add. We want to add the ID, title, image path. You see showing here. Then you can resize the view to see what the column is inserted. Then you can see it's very similar to the table, include the columns you want. Then it is when you want to select for showing in the web page, you don't need to search and show in the album. You don't need to search in the photo table. You just need to query the DL photo view, the view. I just showed you to create a view for one table, one entity. But you can also use the view to grab the data from multiple tables that use the join. And this is another example. Can use the view. We're showing the photo. You see we show the title, and also we show the uploader, the name of the member who upload the data. In this case, we need 2 tables. One is the photo and the member, these 2 source data. And the database view we need is a browse photo view. And now we need the data from both the photo and the member, the title, image path, and the name of the member to show into my view. So let me just show you how to create this view in Visual Paradigm. Okay, let's create the second view. Instead of create a view from the toolbar, you can do another way. You select the table you want to create a view. You can hold the control button to have a multiple select, or you can use the box to select 2 tables. And then you click the create view. Then you see the new view is created. Let's just name it. We name it browse photo view. Great. Let's just make it a little bit bigger. Then we look at the bottom. You see we already helped you to make the join. Because we find that the member ID and the ID is linking between them. We talked about this, the foreign key, in the previous lecture. Then we can select what we want. We want the photo title. We want the image path because we need to show the photo. And then we also want the member name. So it's that easy. Just create it. And there is one more advanced features you can use when you use the wheel. You can apply the filter to ensure the only relevant data you want is showing up in the wheel table. Let's just take another example. Say we suggest to show the recent photo. We just show up which photos we just uploaded 5 days within the last 5 days. So we base on the browse photo wheel to enhance to support the recent photo. You can see we have the upload date stored in the photo entity, which showing when you upload the photo. And then we can add this upload date to the browse photo wheel and add the filter to filter only the photos you uploaded within 5 days. Let's see how it works. Okay, we add the photo upload date. Now you see the upload date showing here. And then on the right hand side, you see the photo upload date. On the right hand side, you can set the filter. You see we have 4 filters. If you need, you can add more. And you can input the criteria you need. Say this is greater than sys date -5, things like that. And the syntax you input here should be follow the syntax of the database you want to generate. The database will be used and will be generated when you generate the database from Visual Paradigm. Then from now on, when you query the browse photo view, then you will got only the photos you uploaded within the 5 days, within the past 5 days. Let's summarize what we talked about in this lecture. I'm introduced the concept of the database wheel and talk about to use the join to create a database wheel and to apply the filter to filter the data. Then you can get only the relevant data from the database wheel rather than you sort it out after you create it. Thank you very much for attending this lecture. See you soon in the coming lecture. Triggers and stored procedures. Let's talk about the triggers first. In database, the trigger is a procedure that will execute it automatically when something happens in your database. The something I'm referring to is that you can insert the data, or you update the data or delete the data in your database. Let's take an example. The trigger can be used in the auditing purpose. As the system keeps running, you will keep modifying the data in the database. For some reason, you may want to know the answer of following questions. Who modified the price of the milk to $320? It's crazy. I suppose it's $3.20. You want to know who made the change, what is the time to make this change, so we know the impact. Then the trigger is useful in this place. Trigger can use it to audit your database. Let's say if someone update the database, of course we're talking about update is update through some information system rather than typing the SQL. Then the trigger will be executed and it can record the changes in a log in the database. So the type is update and the username who made the change is WG Wong, WG Peter, and the time is 2nd of May. Old value is $8, the new value is $3.20. So you can record this one, and then when you find the data has a problem, you can go back to check. To create a trigger in Visual Paradigm is easy. you just go to the triggers item on the toolbar, drag and drop into the diagram, and then you will create the triggers. Please note that this is a triggers, not single trigger. It is a container of a set of trigger. So the triggers is a logical container. Then you can write a lot of trigger inside. After you give the name of the triggers, then you can right click to new the trigger, and you can also use the shortcut key Alt Shift and T pressed together. Then you enter the name of the trigger, and again you right click on the trigger, open the specification, or you press enter. Then you go to the specification dialog box to enter your trigger, and after that you can click OK to finish to the trigger creation. Please be reminded that the trigger is running in the database, so the things, the create statement you write in this dialog box should be follow exactly the syntax of your database. If you're using Oracle, you use Oracle standard. If you're running on Microsoft SQL, you use SQL standard. So make sure write the correct trigger. Then we move on to talk about the stored procedure. As its name, stored procedure is a pre-written procedure code that allows you to execute over and over again. It is very useful to do some validation or quick retrieval of data. Here I talk about quick retrieval. Then I will show you an example that we get some data with a calculation. Then you can do it in a database level rather than in application level. Let's take a look on our example. We have a photo table to store the photo, and you see there is a member ID column storing who upload the photo, who own the photo, and we have a privacy column which shows the visibility of the photo. Say public is everyone can browse a photo. Only you, that means only you, the owner, can view the photo. Friends means someone in your circle or in your contact list, then they can view your photo. And the third column is the view. This is the view count. Then imagine you want to produce a chart like that. You're showing the member by member their view count of the public photo, private photo, and friends photo. Then you need to do a lot of database query. You can imagine you need to get the member and then collect their photos and then add the counts up. You need to do it in the application. And if you're doing the application, that's fine, but you need to make sure the performance. Then maybe you do it in the database is a better solutions. Then you can write a stored procedure. Say this is a get photo views, and then it will return the data set which contains the member ID, which you want to collect, and the public count, just the count. It doesn't tell a single photo. Your own count, this is the private photo, and the friend count, which is showing the photos for your friends, how many views. To create a stored procedure in Visual Paradigm is very similar to the trigger. You just drag the stored procedure from diagram toolbar to the diagram and name it. Same as the triggers. The stored procedures is a container which contains one or more than one procedure. So it is a logical container. Then you right click to new a procedure, or Alt Shift P as a shortcut to create. Then enter the name and open the specification, or hit the enter key. Then you will see the dialog box of the specification. You can see the procedure. You can write the procedure like that. This is an example that you declare some variables and you create a temporary table. Remember, the procedure is running in the database, so you can do whatever you like in the database level. You just create a table, and then you fetch the data, and then calculate the sum, insert into the table, and then continue the loop. Then you return the information to the query user. To doing in database level, that can keep the performance very good, and also can make use of internal information rather than get a lot of data and then do the processing in the application server. And finally, you just click the OK to confirm the procedure creation. Let's summarize what we talked about in this lecture. We talk about what is a trigger, just basic ideas about the trigger and give an auditing example, and how to create a trigger. And then I talk about what is a procedure and give an example that you collect the wheel count or different types of photos, and show you how to create a procedure in Visual Paradigm. Generate database. In this lecture, I will talk about how to generate the ER diagram you draw to the physical database. I will outline the steps, and then I will demonstrate how to generate. Let's outline the step. First of all, you need to go to the tool menu in the toolbar, and then click the DB and generate database. After that, you will see the database generation dialog box. Make sure you take the export to database option that will generate directly to the database. I will talk about different options in the rest of this lecture. And then click the database option. Then select the database you want to use. In my demonstration, I will use the MySQL, but Visual Paradigm support a lot of database vendor, so you just go ahead with your own frequently used database, and then configure the database option. Click OK and OK again to generate. Then you will see all the table is generated to the database. Let me just show you how it works. Here I have the MySQL database online photo album, and as you see, as there's no table yet in this database, then I go to the Visual Paradigm. Here is the online photo album ERD. We go to the tools, DB, and generate database. Now we in the generate database dialog box. Let me just take the export to database. And let me just change to my document folder first. And then we go to the database options to select the database you want. I have the MySQL and the driver I downloaded previously. You can click the download to pull the driver from internet. I will talk about more about this later on. And then the host, my database is running in the same machine as this one. And the database name, let me just test. Okay, that's great. Then OK, and then I just click OK again. Then it will want only the InnoDB supports a foreign key. My database is InnoDB, so that's okay. Then just generate. You can see it executing the SQL. Now it's generated. Then I go back to the MySQL workbench. You see the table is now generated, the column is empty. Of course, I just generated from the Visual Paradigm. Okay, let's continue to talk about database generation options. First of all, we use the export to database. By default, this export to database is turned off. The reason is the export to database means you generate directly to the database, you connect to the database engine. And in case you don't have the database right away with you, then you don't check it, then you just generate the DDL. And because I'm doing demonstration, I generate directly. Instead of export directly to the database, you can generate the DDL. DDL stands for Data Definition Language. It is a syntax for define the database, just like create a table, drop the table. Very often, you don't have direct access to the production database. Of course, it is running day-to-day business. In this case, you better to generate a DDL and then execute the table creation script while the software is installed, or you automate the table creation process as part of the features, something like that. And in next lecture, we'll talk about how to patch the database. Is even more interesting about to automate the execution. You can generate the comment and take this box. It will generate the description of the entity and the column you put before into the script. Please be reminded that not all DBMS support the comment. As far as I remember, the Microsoft SQL can run comment. The reason you put the comment is the DDL you produce may be incorporated into your source code repository. In this case, you can get a well-commented DDL is much better than just a plain SQL. The other option is very straightforward. Generate the uppercase. It's forced to generate the uppercase of all the statement. It's just to conform to your team or company standard. And formatted SQL. You can turn it on if you like to have a more human readable format. In the left hand side, you see what the DDL will produce if you don't check the format SQL. We try to generate everything in a single line, which is very efficient for machine to read, but not efficient for human to read it. If you take the formatted SQL, you will generate the SDDL like that. You have the table declaration, and then each column will have its own line and have a very clear indentation to make it easy to read by human. And the header, you can define the header for your database generation. You can add the name variable, time variable, author. Then we will fill in this variable when generate the DDL. And you can also have some custom DDL at the header, like you run the show table first, etc. You can also split the DDL into multiple files. We don't suggest to use this one, but for certain situation, maybe you need it. Then you can have a DDL just for creating the table, and another DDL for adding the foreign key. Separate, create, drop DDL. You can take this option to split the table creation statements and the drop statement into two files. It is a good practice that to avoid you to drop the production data. Please be reminded that this option is only available when you pick to drop and create database in the generate combo box. And we have a generate sample data. It is a very interesting feature. When you design the database in Visual Paradigm, you not only define the structure, but you can also define the data on it. Just like here, we have the photo and the data for the photo. So you can put in some predefined data. Then you may ask, why I need that? I developed a system to do the information we insert to the database. The reason we have defined the sample data is to give the developer have some ground to do the development instead of writing some basic code everyone. Imagine you develop a POS system, the point of sale system. You define the basic products in your sample data. Then when the developer load up the database, they got a 10s or 20s products. Then they can start develop the core features rather than focusing on the inventory input and editing, things like that. So you can prepare the sample data for development purpose, and then you can enable all the team have common set of sample data. Of course, for the development, you turn it on, but if you generate the DDL for production purpose, you need to turn it off. Go ahead. It's very convenient. The code SQL identifier. Database has some reserved word like select, order. This is a reserved word. If you want to use the reserved word as a column name or table name, you need to have the call to call it. Then the database know, the engine know you're referring to your column rather than a certain index of the database. So if you turn the call on, then we'll help you to call the identifier. If you're not sure what it is, please keep it octo, then we will help you to determine. However, we don't recommend you to use the reserved word, because if you use the reserved word, not just affect the DDL, it also affect how to access the database. You write the SQL, you need to call it, otherwise it will be a syntax error. So try to avoid to use the reserved word. Very common, you may use the order as a table to declare there is the sales order. So we suggest you to use sales order rather than order. The column order. By default, when you generate the DDL, the column order, we will follow the order you see in the ERD. In this case, we have the title and then the ID. Then we'll generate the title and ID. You may aware the ID is a primary key. We have a ID, the key icon here. If you want, you can ask Visual Program to generate all the key and index first, then the normal column. If you turn it on, then the ID will go before the title. The order of the column may affect how to insert the data, so make use of it carefully. Again, it's a good practice to put all the key and index in the top of your database design rather than mix it up with a normal column. That will increase the readability. DDL extension, you can define the generated file as an .ddl as extension or .sql. It totally depends on your team convention. Connection provider, it is the strategy for obtaining the JDBC connections. Visual Program use the JDBC to connect to your database server. We suggest you just leave it as it is. You don't need to manage it because it's just generate. The efficiency is not very demanding. Connection. This is for this option is exclusive for you generate or Hibernate, the Java ORM class. The Visual Program not only generate the database, it also can generate the Java code for you to access the database in a totally object-oriented manner. Here you define how to access the connections. You can use the standard Java JDBC connection. You can use the data source, which is provided by the application server, or you can use the mixed strategy. Basically, you use the Hibernate most likely in the application server. So the data source could be the best choice because you can share the connection pool between application. Database configuration. We'll move on to talk about how to configure database. The first things you see in the database configuration is a language. Again, it is exclusive for you generate the Hibernate. If you're not going to generate the code, you just generate the database in Visual Program, just leave it, use the Java. And then you see a list of database vendor on the left hand side. You see it is a checkbox rather than an option. That means you can select more than one database you want. The allowable data type when you're doing the modeling is follow the database you select. Like if you pick the Oracle as a default database, then we will show numeric rather than integer. If you pick MySQL, we will show int, things like that. The database DDL generated syntax is based on the default database option. You can right click on the database and set it as a default. Use the pop-up menu. And then on the right hand side of the screen, you will see the version. You pick the version page close to the database engine you use. Visual Program keeps supporting the latest version of the database engine. So keep updating your visual paradigm can get the best option. Choose right version, and then you pick the driver. The driver is the component for visual paradigm to connect to your database. There are different driver supplier in the market. Pick the one you use most frequently, or you use the default one from visual paradigm. The driver file. JDBC is a very popular database connectivity option, and visual paradigm use the JDBC to connect with your database. In order to connect your database through JDBC, you need to provide the driver. You can click the download button on the right hand side to download the driver from the provider directly. And some provider like Oracle doesn't allow to download the driver without registrations. In this case, we will show through the web page. You go there to download the driver, and then you can select the full file in the visual paradigm to point to the driver file. The driver class and dialect. Driver class is related to the driver file you select, then it depends on the class. The dialect is for the Hibernate to talk to the database. Hibernate is a very sophisticated persistent framework. It supports different dialect for optimization of speeds, optimization of the response time, things like that. So you define different dialect. Of course, we suggest you to keep use the default one first until you understand what you are doing. And then the connection URL, you specify the connection detail to your database. This connection information only useful if you select export to database. Username and password, enter the correct username and password. You may see the engine if you use the MySQL or MariaDB, and you pick the right engine to use. The most commonly used engine is the InnoDB. We suggest to use InnoDB. It has the foreign key support, constraint support. Then you can click the test connection to test. Make sure the connection value you fill in is correct. If you haven't tested the connection, then you generate export the database. You will get the error message. Now we move on a very interesting topic: personal and production database connectivity. Database, as we mentioned before, is the key component of an information system. You store all the long-term data in the database. Typically, you will have two databases. One is the development, then the other one is the production. To keep the system stable, your team need to work on the development rather than on the productions. Otherwise, some mistake will be damage the user immediately. So you will do the work on the development, you will make the change and revert your change. After you test all the change, you will put your development into the production. Then you can patch the production database based on the development. Then we have a development database and production database. In visual paradigm, you can define the production connectivity and the development connectivity as a personal. Why we say it's a personal? It is based on different developer. The production settings will be saved together with the database, together with the project, and then when you commit to the Teamwork server, the production setting will stay in server. But the personal setting does not send to the server. The reason behind is every developer will have their own IP address, database name, login username, password. It doesn't make sense to commit the personal information into the Teamwork server. Then the personal information will stay with your machine. It's very convenient. Then when you when you need to roll out your software, you just change the production and generate again. Let's summarize what we talked about in this lecture. We overview to generate the option and show you how to generate the database and how to configure the database and the setting of the production and personal database connectivity for different purpose. Patch database. In this lecture, I will talk about how to patch the database structure using Visual Paradigm. Let's take a scenario. You have the online photo album and you keep releasing new features from version to version. The information you keep in the system will change all the time. And you want to change the information, it is unavoidable to change the database structure. You may need a new column, even a new table. As we said before, the database is an important component of your information system. And to introduce a new database structure, you cannot just throw away everything, reinitialize all the database, re-input all the data. Then what you need to do is you need to analyze the differences of the existing version, the production database, and your new version, the new database design, and then apply the differences to the production database. And we call this process a patch database. Most likely it will do when you roll out the new version. We suggest you make this process automatically when you roll out to new system, like you put it in a script or you put it in the initialization file of your new version, rather than do it manually. It can make a lot of error and slow down the upgrade process. To generate the upgrade, to generate the patch from Visual Paradigm is easy. You just go to the DB and generate database. The differences is you change from generate database to update database. Let me just do a quick demonstration to you before we move on. Here is the database we created in last lecture, online photo album. Let's take a look on the photo table. You see, we have the ID, album ID, etc. to the image path. And now we go to Visual Paradigm. This is the entity relationship diagram. We used it to generate such database. For example, we need to add a new column in the photo. We just add a new column. Say this is upload device. And you just store the in. This is used to store the photos is uploaded from the web browser or from your iPhone or from your Android. It saves the device which upload this photo. And assume I make that change now, finish my change in the new version. Then I just need to go to the tools, DB, and generate database. Under generate database, what I need to do is I change to update database. I just changed the path to store in, say, my desktop. This is patch. And now you see I uncheck the export to database. I don't want it to execute directly to the database. I just want to get the script. Then I click OK. And then don't show me again. And click OK. Now it will generate the script. Let me just open the file to take a look. Just here. Let me just open the DDL and you will see, after I open the DDL file, you will see there's an alter table, add a column. I can copy this path, copy this text, and go to the MySQL client, paste it, and execute. Sorry, I just put it in the wrong database, so I need to use it in this database. It's in the testing database. So let me just do one select first, and then I use this editor, and then I paste and execute. You see now I added the column. I just refresh. Now you see the upload device is added to the column. You can imagine you just put this script in the upgrade version script file. Then it will upgrade the database automatically when you roll out the system. Of course, you need to test it before you do that. But the idea is simple. You just keep doing your development. You don't need to care about the database change. Once the development is finished, you decided to roll out to new version. You just go to DB, generate the update script, get the script, test in the testing environment, and then roll out. So it is so simple, right? There is a very important option I would like to use the rest of this lecture to discuss. There is a checkbox called Include Job Table Column that not exists in ER model. You need to use it very careful. Let's talk about the consequence first. When you drop a table or column, if you drop a column, all the data in this column will be removed, will be deleted permanently. At the sometimes something like that, if you drop the table, it drop all the columns and all the data will be erased from your database. You dropping a table and a column, usually it's a very significant change. If you do it inappropriately, you may lead to a irreversible data loss. Then how it would happen? When we analyze the database and your design, if you find that there is a column in your database, like the view in your database, but it doesn't show up in the entity in your ERD, it doesn't have the view column. We cannot, as a visual product, we cannot assume that you don't need this column. Maybe you manually go to the database to create a column for fixing some urgent issue. So we will not delete it. But if you are really sure you don't need the column, you can take this checkbox and then we will help you to delete this column. So that's why we leave this option unchecked as the default, and you need to use it with a very careful before you really take it. Then you just click the OK to generate a patch as I demonstrate. Let's summarize what we talk about in this lecture. We talk about the concept of database patching, and I showed you how to patch the database, and I also cover the delete column or table, the consequence. Reverse database to ERD. To maintain or to migrate a legacy database is not an easy task, especially when there is lack of documentation or even no documentation. To ease this process, in Visual Product, you can visualize the database to the ERD through the database reverse engineering, and then touch up or modify your design based on your requirements. After that, you can patch your change back to the database. Then the database will become maintainable, or you migrate to another database as you want. In the following section in this lecture, I will talk about how to reverse the database. I will outline the step first, and then I will demonstrate how to do that. To reverse the database, first you need to go to the Tools tab, and then click on the DB and Reverse Database. Then you will see a dialog box. I don't walk through the options here. I will talk about it later on in this lecture. Click the Next and configure the necessary database connection options. Then click the Next, and now you can select which table you want to reverse. You may have a lot of tables, some system table or some table from different system you don't want to incorporate in the reverse. You can filter them now. Then click the Next and finish your preview what you reverse, and then you can drag and drop the entity into the ERD. Then you form a proper entity relationship diagram. Let me show you how to do it in Visual Paradigm. Here I have the visual paradigm. This is a new project. I want to show you in the new project easier to understand. Then go to Tools and DB Reverse Database, and I just leave it as it is. Click Next and select the database engine. I reversed my SQL. The connection URL is 172.0.0.1. Database is online photo album. Let me just test the connection. It's success. I click Next. Then you can select what table you want. But by default, we put all the table. If you don't want, you can click and send them back. Things like that. Since the album connecting to this table, so you will remove it. It will remove all. Then I just want to put all. Then I click Next and Finish. Now you will see a list of entities reversed. What you can do is you can drag and drop the entity into the ERD. You see, when you drag and drop the entity, we will visualize the relationship for you by default. The reason we provide list rather than show all the entity into the diagram is we allows you to create multiple ERD instead of single. So you can create another ERD and to accommodate different entity. Then you can drag and drop everything on it, something like that. So we will show all the table. That can help you to build a multiple ERD rather than a giant entity relationship diagram. Let's move on to talk about different options. When you reverse the database, you will see a lot of options. The first one is the language. You can select what method you want to connect to the database. You can select the Java, the JDBC driver is used, or if you're using C#, it is using the adapter file. The second option is the result. How's the reversed result showing? This is what we see the list, and default it is a pop-up entity list. Let me just show you the differences between this option. The first one is the pop-up entity list. What we just doing is we provide list, and then you can drag and drop the entities into the ERD, and that helps you to develop a multiple context-based entity relationship diagram rather than a giant entity relationship diagram. The second option is to create a brand new entity relationship diagram and place all the entities we reversed it to it. The third option is to reverse the entity into an existing ERD. You need to use it with care, and that may mess up your existing design. But if you're sure that your reverse is just adding some new table into the entity relationship diagram, that's fine. You just do it this way. Or you don't form any diagram, you just reverse it to the repository. Then you can drag and drop to the diagram later on using the visual paradigm. Regarding how to reuse the elements in the model repository to the diagram, you can refer to the visual paradigm essential online training course. Then the third option is the reverse table. You check this if you want to reverse the table to as an entity. If you uncheck, we will ignore all the database table. This is useful if you just want to reverse the stored procedure or the trigger. You can include a synonym. This is the alternative name of the table or view. Please be reminded that the synonym option only support in Oracle database. Only Oracle database provide this synonym. So if you reverse the Oracle, you can check it. The fourth is reverse stored procedure. You can check this option if you want to reverse the stored procedure. You can refer to lecture number 8 about the detail of the stored procedure. Uncheck this if you don't want to reverse the stored procedure. The trigger, similar. It is reverse the database trigger. Again, you can refer to lecture number 8 about the trigger. If you uncheck it, you just skip it. This option is about how to treat the starter procedure and the trigger after we reverse. If you take this box, by default it's ticked, then we will create a procedure shape and put all the procedure inside the single procedure. It's just like grouping all the procedure in a single shape is easier to manage. Or you can uncheck it, then we will create a shape for each procedure. Then you have plenty of flexibility to drag and drop to everywhere. And this option governs both the procedure and triggers. You can select where to store the reversed entities. By default, it will put into the root level of the project, but you can create a model and store the reversed entities. It is very helpful when you have a very large database, a very large system. You don't put everything in the root. You can put it in different model. It's just like the folder. Again, if you want to know more about the model concept, please refer to the Visual Paradigm Essential Training course. I'm just showing you reverse the database from the online database. Sometimes you may not have the connection direct to the working database. We also can reverse the data definition language, the DDL, which is a text file. To reverse the DDL is similar to the database. You just go to the Tools, DB. This time you choose Reverse DDL. And in the Reverse DDL dialog box, you select the DDL file and tell us what kind of database you are reversing. It is important, even we don't connect to your database, but we need to know the data type with what you're referring to. So you need to specify the database and then select the encoding. Basically, it's a UTF-8, but you may have a special setting. Then keep the generated ELD checked, and then click OK, and we will reverse the entity into the ELD for you. So it's easy and straightforward. Let's summarize this lecture. We talk about how to reverse the database in ELD and how to use different database reversal options to control the reverse behavior. And I also tell you how to reverse the DDL to the ELD. Hibernate. In this lecture, we will talk about the Hibernate and how to generate the Hibernate mapping Java source code from Visual Paradigm. We focus on the Hibernate, so if you are not using the Java as a development language, you can skip this lecture and move on to the next lecture. First of all, we will introduce what is an Hibernate. Hibernate is an object-oriented framework. It's designed for Java. Java is an object-oriented language. The nature of object-oriented is each objects are interconnected between different objects. If you look at the database side, database is more tabular form with the relationship with other data set, which is also a tabular format. You can see the mismatch. The Java code, the object-oriented, is interconnected, focused on the Java. And the relational model is more on the data and the relationship. So you can see the mismatch. And this mismatch will cause the persistency of a Java object. It will be very challenging. Let's take an example. We have an inheritance class like this. The photo is a superclass, and the wildfire and the landscape is a subclass. And how we store this kind of structure in the relational database. To solve this problem, we need an object relational mapping, maybe in short called ORM. The object relational mapping is a tier that helps you to translate your objects in Java into the relational model, which you can save into the database. And the most famous object relational mapping framework in Java should be the Hibernate. It serves the purpose that to translate from object to relational data, or from relational data back to the object form. The Hibernate is a part of the community of Red Hat projects. It is an open source project, so you can bundle the Hibernate library with your projects without extra cost. And the visual paradigm will help you to generate the Hibernate mapping. That is a lot of challenge of deciding the Hibernate. Then we move on to talk about the mapping between the object-oriented and the relational mapping. In this example, as this training course, we focus on the database design. So we start from the relational database, we start from the entity relationship diagram. In Visual Paradigm, you can generate the class diagram from the entity relationship diagram, and vice versa, to keep synchronized. To generate is easy. Let's take a look at the steps, and then I will do the demonstrations to you. First, you right click on the entity relationship diagram and select synchronize to class diagram. Then you can select where you want to generate. You can generate to a new class diagram, or you can select an existing diagram to generate the class diagram. Optionally, you can skip some entity you don't want to generate to class diagrams. Of course, it's optional. And then you click OK. Click OK to generate the entity relationship diagram. Let me just show you how to generate the class diagram. Now I have the entity relationship diagram here. I can right click on the entity relationship diagram and select synchronize to class diagram. Then I click it. Now I can configure where I want to generate. If you already have some class diagrams in this project, you will see the list. This is a new one, so I just name it online photo album class diagram, things like that. And then I can generate. Okay. Then you will see the synchronize to class dialog box. I will walk you through later on. We just click OK. Then now you see it is the class diagram is generated. It's almost same as the entity relationship diagram. I will talk about the mapping in the rest of the lecture. Let's talk about the options you can change, you can configure while generate the mapping. First, you can select where to place the class and the class diagram. You have three options. One is you can same as the source model element. It depends on where this the class, the ERD is placed. Then we place the class diagram next to it in the same parent. Or you can generate to the root, which is we don't suggest. Or you can select another model to generate. The model is something like a folder in the file system. Then you can put it in the model. It's also a good practice. You put the entity in one model. This focus on database, and another model focus on the class. So you can specify. The next option is you see a list of entity and column will be synchronized. On the left hand side is the table and the column name. You see photo have an ID, title, description, etc. And on the right hand side is the class. We will generate and the attribute. You can double click to change, say, I don't want to generate the title as an attribute. I want to generate to something else. You can say photo title, something like that in the attribute. The name you put here will direct impact to the code generated. If you say it to photo title, then when you generate the Java code, you will have the set photo title rather than set title. So use it with care. On the bottom, you can export the mapping into the Excel file. You may be very interesting why we export it. You export to the Excel file, and then you can change it in Excel in a very convenient tabular form. And then you import your change back. Then you can change all the mapping with your standard, like you put the underscore before the attribute name, etc. You can also enforce some numeric and decimal type to be generated by using the type mapping option. On the bottom of the dialog box, you see there's add a stereotype PK to the ID attribute. You can add a PK stereotype to the attribute in the class diagram if it is a primary key. It doesn't affect the code generator, it just affects the appearance. Then you can easy to see, oh, this attribute is the primary key in the database. Then you click OK to generate. We just showed you generate the class diagram, and the similar procedure can apply from class diagram to ELD. It depends on where you start. Some team start from the object model. You draw the class diagram first, generate to ELD. Some team will design the database first, or you have a legacy database which is running today, so you can reverse it to the ELD and then generate a class diagram. Regarding the reverse engineering, you can refer to the previous lecture in the same training course. Let's look at the mapping in detail, how it maps inside the visual paradigm. First, the object, the entity in the ELD will map to the class in the class diagram. And very straightforward, the type column will map to the attribute in the class diagram. There are one option. If you don't want to generate the attribute for the database column, you can set the property by open the specification of the column and set synchronize the attribute to no. You have a different reason to have this option. Something like you have the column which is auto-calculated using the trigger. You don't want the class diagram have direct access to it, then this program will not access to this column. Then you can turn it off and you use your trigger to calculate. On the other way around, if you have attribute in class diagram, you don't want to generate to the column in the ELD, you can also set the persistable to no. Usually this is a kind of a transient attribute. You just use it to compute the value in the memory model. You don't want to save it. Then you can set it to no, then we will not generate the column to you. We move to the relationship now. In ELD, we have the relationship. Then generate to the class diagram, we will have the association to correspond the relationship. The foreign key relationship in the ELD have different things, different relationship type. First, you have a one-to-many. Then when you generate to class diagram, you will have the 1 to 0 to many association. If you have a one-to-one relationship, it's straightforward. To the class diagram, that will be a one-to-one association. If you have a many-to-many relationship, we have an associated table in between. Then we will have the associated class, which represent the middle objects. Let's move on to a more advanced topic we talked about before: how to handle the inheritance, the generalization in the ELD. We have different strategy. First, you can use one table to store all the attributes in the hierarchy. In this example, we have a photo class as a superclass, and we have some attribute I color in red, and the wildlife and the landscape. You have a different types of attribute. The first strategy is to put all the column into the same, all the attribute into the same table. Then you see the Boolean. and we use a discriminator column to distinguish what this table row is representing in which object. You can imagine if you save the data to the database and you load back, the Hibernate need to know this row is representing a photo or a wildlife or a landscape, things like that. The second strategy is to have a table per subclass. Then you will got a very similar structure. You have a photo, wildlife, landscape class. Then you have a photo, wildlife, and landscape table. This can save a lot of space. You see, we don't redundant the column. But this strategy have one problem, is the performance. You can imagine when you load up the object, load up the row of data to the object, you need to query to more than one table, at least two, to get the objects back. So the query time will be a little slower than the first strategy, but that saves a lot of space. The third one is a table per conquest class. It's similar to the one table per hierarchy, but it will only create the enough attribute. Like we have a photo, then you just have a photo column. Then the wildlife will have the wildlife column plus its own the photo column plus its own column. The landscape will have the photo column plus its own columns. And this is a quite good strategy. But if you have a very complicated hierarchy in your superclass subclass structure, this could cause a management problem. To configure the strategy is easy. You just right click on the superclass, the top of the organization structure, open the specification, and then you go to the ORM class detail. Then click on the subclasses and select which the strategy. Select the class and change the strategy to table per class hierarchy, table per subclass, or table per conquest class, and then you just apply and close the dialog, and then you're okay to exit the specification dialog box. Okay, now we move on to talk about how to generate the Hibernate code. To generate the Hibernate code, you just go to the Tools tab in the menu and select the Hibernate and click Generate Code. And then you select the output path for the generated source code. If you are using an IDE like Eclipse, it's easy. You're just pointing to the project file. And then you can configure different code generation options. And you can go to the database tab to configure the database option. And this is necessary because we're talking about we really will save the object to the database. So the database option is important. You select the DBMS we talk about in code generation and configure the database connections. Click OK. And then you click OK to generate the source code. After you generate, you will got a set of source code together with the Hibernate library. We will bundle the library for you, add to your projects. Then you can start coding. And from now on, you can just write the Java code without single SQL to save your object to the database or load it back. I don't want to make this lecture so long, so I don't demonstrate how to programming, but you can find a lot of resources in Visual Paradigm websites about how to do the programming. It's easy and very intuitive. Let's summarize what we talk about in this lecture. I introduced the Hibernate, and it is an open source persistent tier that you can incorporate in your projects without adding any cost. How to map from ELD to the class diagram. I talk about the basic idea of the mapping and show you the relationship, how to handle from the foreign key to the association and different kind of inheritance strategy. And finally, I showed you to generate the database and the code Database design best practices. In this lecture, I will share some techniques to make good use of visual paradigm to improve the productivity and stability of your database design. Let's take a look about the typical approach of the database design development in our software development team. Typically, we will develop the initial database by the development team altogether. This will have quite a small numbers of tables and columns just for initialize the development. However, from time to time when developer need tables or columns to store their information, they will add the tables and column by themselves. Ideally, everybody will update the data definition language file, the DDL, for initializing the database environment when we roll out to the production. But the problem comes when someone forgot to update the DDL accordingly. Then we run into the productions will have a lot of problem because some columns or table are missing. Nowadays, we have some visual development environment bundled with the database vendor like the MS SQL, Oracle Designer. But it doesn't solve the second issue, is the duplicated columns. Since we don't have any control, so everybody can add the columns, add the tables they want, you will come up with a column called email to store the email address, and also another email address to store the email address. So that will lead to the data inconsistency. Furthermore, the database specifications will become outdated immediately because nobody will spend time on both. They will just rushing on create a column and do the programming. Visual Paradigm suggests an approach that you can maintain the good design together with an efficient. We suggest you work 2 team members as the database designer. Here, the 2 team members does not need to be a full-time designer. They just responsible for update the design if they request. And let's take a look. If someone just asks, I need a table to store a deletion histories, then they will say, okay, let me just add a table. And if someone wants to have a column to store the email address, they will add the email address columns, and they will also update to write the descriptions of the column. We said we need 2 people. Is if someone is on leave, you still have the other one can pick up the work. And the database design after you set up the initial one will not be so heavy. So we just need to have some part-time workload, the role to maintain it. And the idea is after they update the database, they just commit to the repository, and the developer can get the design immediately and generate the update the database, the development database they want to continue the development work. Let's take a case studies on it. Assume we have a team of 5 people: John, Peter, Russell, Mary, and David. Assume John is worked as a database designer. To keep it simple, we just pick one. And Peter just want an extra column to store the email address. Let's see how it works in action. First of all, Peter will create the task to join in the Taskifier. The Taskifier is the task management system in Visual Paradigm. You can make use of it. It's free of charge in the repository. He just create a column and state why he need the column. And John will receive the notification and open the task. And then he update the database to see any duplicated column. If no email before, he just add the email column. And then he write the descriptions, who request and what's the purpose. John will commit the change to the server and mark the request URL as a comment when he commits to the Visual Paradigm server. And then John mark the task complete. Now back to Peter. He find the task is completed, then he can update the change from server and generate the update database script to upgrade to the updated development environment. Regarding how to do the update, you can revisit the previous lectures. We talk about how to update the database instead of reinitialize all the tables and columns. The benefit of this approach is we have a common database environment for the entire team. Everybody, when they update the change from server update, generate the update script to the development environment, all the team member has the same database environment. They will see the email address immediately after John just committed. And there's no duplicated column anymore. And since John will do the safeguard to avoid duplications. And the great benefits is the production database is ensured to run without any issue. Finally, the documents are always up to date because John is keep updating the table and descriptions. The second technique I would like to share is to design for very large database. If you're developing a very large system, most likely you will have a very large and complicated database design. Without help of the design method, to maintain and design the large database is very complicated. In Visual Paradigm, we suggest to use the context-based database design, and you can draw multiple database design diagram instead of one giant entity relationship diagram. The team member can focus on a smaller set of the table instead of finding which table relating to each others in a very big database design. With the context-based design, you can reuse the entity in different design. In this example, we reuse the photo table in photo upload ELD and photo commenting ELD. When you update one of the photo table in either the diagram, it will reflect the change in others. You don't need to spend your time to keep it up to date and consistent. To reuse the entity is very simple. You just need to press the control space when you create the entity. Then you will see a list of the list of entities you already created in your projects, and then you just pick them. Then you will see the full detail showing in the entity relationship diagram. Let's summarize what we talked about in this lecture. We talk about the typical approach of database design and the typical problem. We have suggested approach for database design and development. We also propose to have a multiple entity relationship diagram to do the database design for very large systems. Generate data specification. The data specification is a kind of document that shows the data structure, including the entity, the columns, and the relationship. That for the developer to read, to understand how to use the database. It is especially useful if you have a new team member who can read the data specification and get familiar with the database architecture of the system. Or you're maintaining multiple systems and you don't need to focus on one system. Then when you switch back to the application, you can read the specification first. Make sure you understand the structure. The data specification usually come with the entity relationship diagram, of course, to show what entity included and the relationship. And then you will see the entity details of the entity relationship diagrams. To generate the data specification in Visual Paradigm is very easy. You can right click on the empty space of the diagram, click the utility and generate data specification, or you can use the action bar. I will demonstrate how to use the action bar in a minute. And then you will preview the specification in the document composer within the visual paradigm. If you think it is good, you can do some touch up, of course, and then you can export the document in different formats, and you specify the path and export, then will generate the document to the normal format, including the PDF, HTML, and the Word. Before we move on about the details of different types of document, let me demonstrate to you how to generate the data specification from Visual Paradigm. Here I have the entity relationship diagram of my online photo album system. To generate the specification, you can open the action bar. We talk about using the pop-up menu in the presentation. I want to show you another way. You can open the action bar and make sure you haven't select anything. So you need to click on the empty space and open the action bar, and then just first item is generate data spec. We just click it. Then you will see the specifications generating to the stock composer. I double click to collapse the toolbar. Then you can see the entity relationship diagrams and each entity and the column. If you put the description, you will see the description after each column. Then you can export to different formats. You can export to Word. Let me just show you how to export in Word. And I select where to put. This is the DB spec, and then I just export. Then the Microsoft Word is generated. You see the specifications and the details were showing in the Microsoft Word. Then you can print it, or you can incorporate other documentation together. Visual Paradigms support different types of documents. You can export to HTML, PDF, and Word. And for HTML, it is good to put into your company internal website, the local area network. Then the developer can go to browse the content using the web browser. If you put it in the PDF file, it is a high quality scalable image. I stress on scalable is when we export to PDF, we not just extract the image and put it into PDF. We put it in the vector file, vector graphic, so you can zoom it in, zoom it out easily, and also good for printing and good for distribution, because most of the devices, including the tablet, mobile phone, that can use the PDF to read the PDF without any problem. For the Microsoft Word, it is good for export to Microsoft Word. It's good for advanced editing. You can incorporate your content, and the Word includes some commenting features that you can get the comments using the Word. I would like to talk one of more advanced concept about generated documentation. Your company may have some documentation standard. You may have your own cover page, own marginal setting, page number, header, footer, etc. When you generate the data specification, you can make use of your company own format. To do that, we need to use the features called Word template. The idea is you can specify the Microsoft Word. Listen carefully, it is a Microsoft Word, not the Word not Word template. It is a docx file. You can define the cover page. You can define the header style of your document. You can set the page margin, etc. And then when you generate the documents, we will put your Microsoft Word template. We call templates, but actually it is a Microsoft Word file only. Then you will put your cover page at the beginning, and then the content will be follow the rest of the documents. Let me show you how it look like. Here we come back to the database spec we just generate. Please remember we have the cover page, we have the heading in blue color, things like that, okay? And so let me just close the Word file and I make a new template, just show you how easy it is. I just create a template to make it more easy to identify. I just put a student report. You have a butterfly. I just create a Word file and then I just don't put anything, so I just save it to the desktop. And then this is the I just put stop at the desktop. This is the template, and then I close the Word and come back to the visual paradigm and I just export. I select the Word again. This time I pick the content. I pick the Word template and I select the template and then I click just let me have some different space _2 and now it export. Then you will see the exported document will have the cover page and it fill in the content of the documents, and then this is the content itself. And now you see the heading will follow your standard. Then you can understand that everything's follow your company standard as long as you specify in the template file. And you see even the page number, the page border, all look nice. Let's summarize about this lecture. We learn about how to generate the data specification, the usage of PDF, Word, documents, etc., and the use of the Word template I just showed you. And thank you very much for attending this training. Have a good day.